In this session, we study the modern periodic table and the periods, groups, valence electrons, etc. Let us see the properties of modern periodic table. Henry Moseley put forward the modern periodic table. The credit goes to Henry Moseley. Later, the present version, the long form periodic table, is the contribution of Niels Bohr. The modern periodic table consists of 18 vertical columns that can be called groups. So 18 groups are there in the modern periodic table. And there are 7 horizontal rows called periods. There are 7 periods and 18 groups are there in the modern periodic table. We identify the given element belongs to which period. Let us see. If we consider an element sodium, electronic configuration of sodium is 2, 8, 1 and it is a valence electron. If valence electron is 1, let's check whether it belongs to group 1. Okay, you see sodium belongs to group 1. Same way, if we consider magnesium, the electronic configuration is 2A2 and there are 2 electrons in the valence shell. Since the valence electrons are 2, it belongs to group number 2. And you consider aluminium, phosphorus or silicon, phosphorus and sulfur. Here you can write 283, 284, 285 and 286. Or also you can consider what we call chlorine 287 or argon 288. See, while looking on the valence electrons here 3, 4, 5, 6, 7 or 8, it is very clear that it is understood that these elements are not belonging to group 3, group 4, group 5, group 6, group 7 or group 8. These elements are not belong to this group. Then how do we identify the group number? Just simple, just add the numerical 10 to the valence electron. Just add numerical 10 to the valence electron so that we get 13 here. Check the group number, we see aluminium belongs to group number 13. The same way, add 10 here, add 10, 10. So we get 14, it is a group number of silicon, and we get 15, it is a group number of phosphorus, and we get 16, sulfur belongs to group number 16. The same way, we get 17 and we get 18, argon belongs to group number 18. So what I told you that if valence electron is 1, it belongs to group 1, if 2 belongs to group 2, or if it is 3 onwards, just add 10 plus to the valence electron. These are the different tricks to identify where or in which group the given elements are placed. And we mainly study group 1 to then 13 to 18. And we don't normally study in this year or maybe in the class 10 from group number 3 to 12. They are known as transition elements that you may study in the coming classes or the higher classes. Let's see the periods once again. I told you already there are 7 periods. How do you identify in which period the given element belongs to? Let's see this example. Hydrogen. For the atomic number of hydrogen, it is 1. So we write in the electronic configuration in the K shell there is 1 electron. How many shells are there? 1 shell. The number of shells says the number of period. Okay, or in which period it belongs to. So hydrogen belongs to period 1. Let's take another example. See, say lithium. What is the atomic number? 3. We write the electronic content K shell 2 and L shell 1. There are 2 shells. So lithium belongs to period 2. The same way, you take calcium, atomic number 20, K shell 2, L shell 8, M shell 8 and N shell 2. 1, 2, 3, 4 shells are there. So since it has 4 shells, calcium belongs to the 4th period. Let's see what periodicity is. See an example of group 1 elements. See, in group 1 the first element is hydrogen. After the hydrogen, next 18th element is lithium. That also belongs to the group 1. After the lithium, next 18th one is sodium. After sodium, next 18th one is the potassium. See, hydrogen, the first member of the first group, the electronic configuration is 1. That means 1 electron in the K shell. Thereafter, next 18th element, lithium, it also has 1 electron in its valence shell. Thereafter, the next 18th one, sodium, it also has what? 1 electron in its outer shell. Again, you see, again after 18th element, it shows 1 electron in its outer shell. That means that every 18th element repeats the same valence electron, or simply if we say reappearing of properties in every 18th interval. The reappearing of properties or repeating of properties after every 18th groups we say periodicity. And the periodicity caused is strictly due to electronic configuration. So periodicity is caused due to electronic configuration. We see how the nature of shells down a group or across a period. So if we consider the group 1 elements, what the electronic configuration of potassium is 1 electron the K shell and 2-1 for lithium, sodium 2-8-1, potassium 2-8, 8 and 1. That means here in case of hydrogen there is only 1 shell, and for lithium 2 shell, and down a group we are going down the group 1. And for sodium, 3 shells are there, and for potassium, there are 4 shells. So what do we understand that? If we go down a group, any group we consider, down a group, the number of shells are increased. Consider the elements of period 2. Here we have lithium 2, neon are written here. See the electronic configuration, 2-1, 2-2, 2-3, carbon 2-4, and finally neon 2-8. Okay. See, in all these cases, from lithium to neon, all these cases, the number of shells are two shells are there, K shell and L shell. If we consider any period, correspondingly, the number of shells will remain same. That means, across a period, the number of shells remains same. There is no addition of shells taking place across a period. Now let us see how the valence electrons and valency observed across a period or down a group. Let us see down a group. See down a group we see the electronic configuration of group 1 elements. They are group 1 elements. Group 1. See two hydrogen with 1 electron the valence shell, 2-1, 2-8-1 sodium, potassium 2-8, 8-1. So all these cases we see valence electrons remain same. That means if we consider any group, down a group, the valence electrons remain same. If valence electrons are same, or if valence electron is same, here in this case, the valency also would be similar, same. That means hydrogen loses one electron, so that a positive 1 valency. Lithium also loses 1 electron, sodium loses 1 electron, the same way potassium also so loses one electron. If you consider any element of group 1, they lose 1 electron from their outer shell, so that you get a positive 1 valency. So the same way if you consider group 17 element, they gain 1 electron, so that all the elements of group 17 will have minus 1 valency. So what I said, down a group, since it has same valence electron, they will have the same valency. Let us see the nature of valency or valence electrons across the period. Here we have period 2 on the board. So since it is period 2, we know there are 2 shells. Okay. See, all the elements, they have 2 shells each. KL, KL shell, K and L shells. And see the valence electrons. Here 1 electron, 2, 3, 4, nitrogen has 5 valence electron, fluorine has 7 valence electron. Since valence electron is 1, it loses, so that you get plus 1 valency, losing 2 electron 2, valency 2, losing 3 electron valency 3, and normally carbon shares, so that valency 4. And since it has 5 valence electrons there, it gains 3, so that you get 8 electron the outer shell octet formation. It has 6 electron their outer shell, so it gains 2 electron for becoming the octet condition. So here 7 electron, it gains 1 electron. Here 8 octet complete, so it will neither lose electron nor gains electrons, so the valency 0. So what we observe here, 1, 2, 3, 4, 3, 2, 1, 0. Left to right or across a period, valency first increases, then decreases. For valence electron, it increases across a period. So what? Repeat once again. Across a period, valence electron increases. Valency first increases, then decreases. Let's summarize what we learned in this session. We learned about modern periodic table. We see there are 18 groups, 7 periods, and with the shells, number of shells increases down a group and number of shells remain same across a period. And we see the periodicity, repetition of property after every interval. 18th group element shows the property of the first group. And we see the valency of a group remains same, and valency across a period first increases, then decreases.